All right, let's do the review packet. So we're on question 1. A value represents gravity. Nice. There we go. The B value is the initial or starting velocity. And the C value would be the initial or starting height. Fix that. Okay. So we have a function here, negative 16t squared plus 30t plus 15. We want to know when the pumpkin will be 25 feet in the air. We're going to use our graphing calculator to figure this out. So let's take a look at the graphing calculator. We'll go to y equals. We'll plug in the function in the correct order here. Negative 16 x squared plus 30x plus 15. And we want to know when that's going to reach 25. If I hit graph right now, I can see part of the graph, but I obviously can't see 25 because I'm on a 10 by 10 window. So I will change that window and make the y maximum because I need to see more of that. I know I need to see at least 25. I'll make it, let's say, 40. Hit graph. I can see it now. And so I can second calc the intersection points. And 1, 2, 3. And there's my first intersection point, 0.43 seconds, about. But we know there is a second intersection point there, because it can hit 25 feet on the way up and on the way down. So we will second calc the intersection again, but this time we're going to move that cursor closer to the other point and hit enter 3 times. And we get about 1.44 seconds. When will the pumpkin reach its maximum height, and what height is that? So we will do second calc maximum, and we want to be on the left side, hit enter, and then we want to be on the right side, hit enter, and enter one more time, and we see our maximum of 0.94 about. So we got 0.94 seconds and a height of, what's that, 29.06 feet. When will the pumpkin hit the ground? So for that, we're looking for that point right there, that 0. So we're going to do second calc, 0. And we want to be on the left side of that x-intercept. So I am on the left side of the x-intercept. Now I want to move right until I cross the x-intercept. So I've crossed it now. So I could just hit enter now. And then hit enter one more time. And there we get 2.29 about. .29 seconds. Number 5, in football, when a field goal attempt is kicked, it leaves the ground on a path where the height of the ball h in feet at time t seconds later might be given by the function h equals 45t minus 16t squared. Write an equation that can be solved to find the time when the ball hits the ground. So we would be taking that equation and we would be setting it equal to 0 because that's the height off the ground when it hits the ground. And then we're going to solve this algebraically this time. And so we can look at this and we can say we could probably factor a t out of both of those. And set each factor equal to 0 and solve both of them. So subtracting 45 from both sides and then dividing by negative 16. So I would have negative 45 divided by negative 16, and I'd get 2.8125. And so our answer, obviously it says it leaves the ground, so that's the t equals 0. That's not really our answer because we're looking for when it hits the ground after it's been kicked. So we're looking for a 2.8125 seconds here. How many seconds will it take for the ball to reach its maximum height? Well, we can use that idea where it's going to be right in the middle there. So what's in between 0 and 2.8? Well, let's just figure out what half of that is. About 1.4. I'll just use the whole thing there. 1.40625 seconds. And then it basically wants to know what the value of the function is. So we're going to plug that value into the function. I already have this in my calculator, right? So if I press graph and then or trace is a nice feature to use. The cursor's on this function, right? And so I can type in any value I want, and it's essentially plugging that value into the function. So I'll just plug in 1.40625 and hit enter. And that's the wrong equation. That was the last problem. My bad. Let's put the right one in. 45x minus 16x squared. And we'll graph that. Okay, that looks a little bit better. Hit trace. 1.40625. Hopefully this one's going to look like it's at the maximum this time. Yes, it does. Okay, so we have the correct equation in our calculator now. Hopefully you didn't do what I just did. Anyways, so it reaches a height of about 31.64 feet. 31.64 feet. There we go. Now, alternatively, we could have just plugged that number into the function, squared it, multiplied it, done all that stuff. Number 6, matching. Rule 1. So looking at these rules, we have a couple different things to notice. I noticed 3 of them have a y-intercept of positive 6, and one of them has negative 6. So the rule 1 is going to be the only one with a y-intercept of negative 6. So that's A. Negative 6 y-intercept. And then rule 2. So rule 2, now we can look at the A value. Those are negative A values, which means those should open down. And so this one has the positive, so it's the only other one. I've already used A. It's the only other one that opens up, so that's going to be B. So the A value is greater than 1, so it opens up. A value is greater than 0. It's positive. It's a positive A value. Rule 3. Okay, so now if we're going to compare Rule 3 and Rule 4, a couple of differences we can notice is that this number is between 0 and 1, so that's actually going to make it a much wider graph. We could also notice, well, let's just stick with that. So this one's going to be the narrow, this one's going to be the wider. So this will be C and D. Look at that. It goes in order. Nice. So Rule 3 matches with C. And how did we know that? Because it's narrower. The value, the absolute value of the a value is greater than rule 4, so it's narrower. Which means this one's wider. Simplifying expressions. Simplify the following radical expressions. Okay. Looks like I didn't update this to reflect what we've done, because we didn't really do anything with variables under the square root. So if you simplified this to just be 12 square root x to the 7, that would be correct for what we've done. Okay, that would be correct. Just for accuracy purposes, this does simplify into 12x cubed square root x, but we didn't really go over that, so that would be correct. Over here, if we're simplifying this one, we can rewrite the 72 as 36 times 2. And so we can take the square root of 36, which is 6. So that goes on the outside, but then it gets multiplied by the 8. So 6 times 8. And then what's left inside would be the 2x to the 4. Okay, makes sense, hopefully. So what do we do here? 6 times 8, 48, square root 2x to the 4. Good, that would be what we would have left, okay? For accuracy purposes, the variable can also be simplified. And that's what we'd get. Anyways, simplify the following expressions. So here we're going to distribute. I'm going to distribute the negative 3. I'm going to distribute this negative sign. And now I'm going to combine all like terms. And so that would give me, what's that, negative 5x and minus 6. Over here we're squaring, so we are doing x minus 8 times x minus 8. We are double distributing, so x times x is x squared. X times negative 8. And then negative 8 times x. And negative 8 times negative 8. And so we get x squared minus 16x plus 64. Same thing here, let's double distribute. So we got x squared, and then plus 3x, minus 3x, and minus 9. When we combine like terms, we just get x squared minus 9, because those two terms cancel out. Number 9, we're graphing these two functions on the same set of axes. So I'm going to go ahead and just use my calculator to help me out here. Let's go y equals, plug in x squared plus 5x minus 6. And I'm going to look at the table, because that's going to give me some nice points that I can fit on this graph. I usually kind of look for that symmetry idea there. So now I can just start plotting these points. I'll start with this one, negative 7, 8. So negative 7, 8 be about here. And then negative 6, 0. -5, -6. I'm just going through the table, plotting these points. So I know the vertex is actually somewhere in between there because of symmetry. Okay, and then I would try and make a parabola shape, which I have not really learned how to do yet on this. I've kind of missed almost all of the points. Hopefully you did better than me. Not too bad. The other one is going to be x plus 6, so let's make sure I know that this is my f of x function. So let's go ahead and label those, because if I have more than one function on the same graph, I have to make sure that I label them so that I know which one's which. So x plus 6, that means, it's a standard y-intercept of 6 and going up 1, right 1. Okay. Oh. Okay. And that's going to be my f of x equals x plus 6. And determine all the values of x where the functions are equal to each other. So I know my graphing isn't really great, but this point was a shared point, 2, 8, and this point here, -6, 0. So what are the x values that make the functions equal? That would be x equals -6 and x equals 2. Okay, because those are the x coordinates of those shared points. All right, quadratic formula. Let's solve this using the quadratic formula. So we got a equals 1, b equals -7, and c equals 3. So we're going to plug that in. So negative b plus and minus the square root of b squared minus 4ac all over 2a. Now I go and do my simplifying. It's going to be 7 plus and minus the square root of 49 minus 12. So 49 minus 12 would be 37 over 2. And the square root of 37 is not going to simplify. So we could essentially just leave it like this, or we could type it out and get decimals, okay? So this is an acceptable answer. If we went ahead and found the decimals, it would be 7 plus the square root of 37 divided by 2. So it's about 6.54. Or x is about 7 minus the square root of 37 divided by 2, about 0.49. Okay, and so that would be the decimal approximations, or we just leave it in simplest radical form, like number 11 asks us to do. So a is 3, and b is -2, and c is -4. So x equals -b plus and minus. Okay. Let's try that again. Negative b plus and minus the square root of b squared minus 4ac all over 2a. So now we simplify. It's going to be 2 plus and minus the square root of, it's going to be 4. This is going to be 16 times 3, so 48. So 3 plus 48, 51. It's plus because negative times negative. Over 6. And 51 we can't do anything with, so we're going to leave it like that. Okay. Solve the next using the quadratic formula. So the next one, make sure we set that equal to 0. So we want to subtract this 3. So we get 2x squared minus x minus 10 equals 0. Now we can plug it. Now we can identify a is 2, b is negative 1, c is negative 10. And we can plug into the quadratic formula. So x equals negative b plus and minus the square root of b squared minus 4ac divided by 2a. And so it'll be 1 plus and minus the square root of, that's going to be 81 when we simplify that, over 4. So what's the square root of 81? Well, it's going to be 9. So we get 1 plus and minus 9 over 4. Okay, so now what are our two answers? Well, x equals, what's 1 plus 9? 10 divided by 4. .25. What's 1 minus 9? Negative 8 divided by 4. Negative 2. Okay? And there we have it. Not 2.25. 2.5, right? I can't really do math in my head right now. 2.5. Yeah. Completing the square. Rewrite the following quadratic equations in vertex form by completing the square and then identify the coordinates of the vertex. Okay, so here we have standard form. So I'm going to do my side work. What's the b value? 6 divided by 2. And then take that number and square it. It's 9. So that's going to give us x squared plus 6x plus 9 minus 20 minus 9. Now I can factor the first three terms to x plus 3 squared. Combine these, negative 29. So the vertex is at negative 3, negative 29. Next one, again, I'm going to do my side work. So negative 4 divided by 2 is negative 2. And then negative 2 squared is positive 4. And so if I'm going to just do my little shortcut method, the negative 2, that means x minus 2 squared. And then I'm going to subtract this value from this. So I'm going to subtract 4 from here. That would give me minus 1. And so my vertex is positive 2, negative 1. Applications. The area of a rectangular playground enclosure at South School is 500 square meters. The length of the playground is 5 meters longer than the width. So, got something like this. And the area is 500. And the length is 5 more than the width. So, when we multiply these together, we get 500. And so x squared plus 5x equals 500. This is a quadratic, so we're going to set it equal to 0. And now we're just going to solve this using an algebraic solution. So that means factor it or quadratic formula. Okay. Are there numbers that multiply to 500 and add to 5? Maybe. I just can't really think of them right now, though. So, $25 and $20, right? Yeah, 25 and 20. So that would be x plus 25 and x minus 20, because that way we will get a negative 500 and we'll get a positive 5 when we add them. That's a 0. That's a 20. And so our solutions would be either x equals negative 25 or x equals 20. And because we're talking about dimensions here, we're not going to have negative length. So x is 20. So the width is 20 feet, meters. And the length, which is 5 more, is 25 meters. Contractor is working to increase the size of a room. The room is currently a square with an area of 81 square feet. The contractor needs to increase both the length and the width of the room, but needs to increase the length by 1 foot more than twice the increase in width for the resulting room to have an area of 120 square feet. Okay, let me change what I've just drawn. So I don't need to label those x's because those are not unknowns, right? This is a square, so I should know what the dimensions of these are. Square of this would be 9, right? 9 times 9 is 81. Okay. So now what we're talking about is we are taking this and we're turning it into a different shape, more like a rectangle or who knows, where if the width is being increased by a value like x, well, the length has to be increased by 1 foot more than twice that increase. So that would be 9 plus 1 foot more than twice, so twice the increase and 1 foot more. So essentially we'd have 10 plus 2x there. Okay, and the area here is 120. So we would have 10 plus 2x times 9 plus x equals 120. And then we double distribute here. 90 plus 10x plus 18x plus 2x squared. Now I'm going to subtract the 120 and combine all like terms, put it into standard form, do all that stuff. So that should be 2x squared plus 28x and minus 30. Now we look to solve this. First thing I noticed that I can factor 2 out. Essentially I can divide everything by 2 to get rid of that, right? I can just divide this by 2 and divide that by 2. So x squared plus 14x minus 15 equals 0. Now it looks kind of a little bit nicer, so I can factor, looking for numbers that multiply to 15 and add to make 14. So that would be a positive 15 and a negative 1. And so x equals negative 15 or x equals 1. So if we're increasing the length and the width by something, we wouldn't be increasing it by a negative 15 feet. That wouldn't make sense. And so we're increasing it by 1 foot. So for the resulting room to have an area of 120 feet, by what should the contractor increase the length and the width? So increase the width by 1 foot and the length. So remember, here's the increase right here, right? So if x is 1, 1 times 2 is 2 plus 1 is 3. So increase the length by 3 feet. Okay? So we solve for x, we plug it back into our expression there to figure out what we really increased this original number by. And that is the review packet. So if you guys have questions, let me know. Drop into my office hours, and I will see you guys later.